All right, for this scenario, we want to try and see if we can create an equation based off of the information given in this little word problem here. That's all we're doing, just making an equation, setting this thing up. So let's first start off with a reminder of what our growth and decay exponential equations look like. The amount of my exponential was going to equal p, the principal, and then 1 plus or minus the rate to the power of t. For time, it could be per year or month or whatever. It looks like it's going to be per year in this scenario. So let's start off by grabbing our important information. So we have Samantha here. She's depositing $350 into a bank. That's looking like that's going to be my P. That's an initial value. Then next piece of information here, I see a 1.3%. That's going to give me my rate. And I have to do a little bit more of this before I just stick 1.3 into my R, but that's going to end up moving in here somehow. And that's really all that I can gather so far. Right now, I'm not given a specific amount of time, so that's going to stay a variable. And I don't know the amount that this bank account is going to be equal to since I'm not given a time. So all we're doing is setting this thing up. So I have A is going to equal my initial deposit of $350 times 1. Now, we have to ask, are we going to be adding our rate or subtracting our rate? Well, this is a gain of 1.3%, so I'm going to be increasing my rate, and I'm going to raise all that to the t power. Now let's just right over here change that 1.3% into a decimal. I'm going to move this guy over 2 places, and my decimal is going to equal 0.013. So we're going to add that inside of our parentheses. My final equation is A equals 350 times 1.013, all raised to the t power. And there you have it.